So guys, when we're using Nmap and scanning for devices to determine which ports are open, there are various basic scanning options. We can do -SS, which performs a stealth TCP scan, okay? That does not fully complete the TCP three-way handshake, and it closes the connection once the service responds, okay? We can do -S_T, which performs a full TCP scan, okay? A full connection is established this way with open TCP ports. We can do a -S_U, which performs a UDP scan. As UDP is a connectionless protocol, these scans can take significantly longer than TCP, guys, so keep that in mind. Or we can do a -P, which tells Nmap which ports to scan. So we can do like a -P 165535, which is going to specify every port, okay? So let's talk about intrusion detection and prevention. So Linux Intrusion Detection System, or LIDS, is a patch to the Linux kernel and associated administrative tools that enhances the kernel security by implementing mandatory access control, or MAC. Guys, don't confuse this with a MAC address, okay? This MAC and the other MAC are two different things. So when LIDS is in effect, all system network administration operations, chosen file access, any capability, use, raw device, memory, and I/O access can be made impossible even for root. Okay, so we can actually control what things can be used. So one can define which programs can access specific files. It uses and extends the system capabilities bounding set to control the whole system, and adds some network and file system security features to the kernel to enhance the security. One can finely tune the security protections online, hide sensitive processes, and receive security alerts through the network, and more. Okay, and you can also use Snort. Snort is an open source, free, and lightweight network intrusion detection system, or NIDS. And it's a software for Linux and Windows to detect emerging threats. Let's talk about PAM here, guys. So PAM stands for Pluggable Authentication Modules, or PAM, and is a common framework for authentication and security. Both the RedHat Enterprise Linux's single sign-on methods, Kerberos and smart cards, depend on underlying PAM configurations. Understanding and using PAM can be very beneficial for planning and implement a secure, efficient single sign-on solution. And guys, I can vouch for this. This is something that's used commonly. This is something I commonly tweak and configure. So PAM uses a pluggable modular architecture, which affords the system administrator a great deal of flexibility in setting authentication policies for the system. PAM is a useful system for developers and administrators for several reasons. First, PAM provides a common authentication scheme that can be used with a wide variety of applications. So we can use the same setup for a lot of different things, and it's going to work just the same, and it's going to provide everything we need. Second, PAM provides significant flexibility and control over authentication for both system administrators and application developers. And finally, PAM provides a single, fully documented library which allows developers to write programs without having to create their own authentication schemes. Let's take a look at PAM real quick. So I'm going to show you where PAM resides. So we're going to go to cat, and PAM is going to be under etc, and it's going to be pam.d. And there's two ones that you really want to look at. First one's going to be system-auth. Okay, let's look at that. So we see some things in here. All right. We see, oops. Actually, I'm going to clear my screen. What we're going to do is we're going to do a VI on that file so I can actually scroll and show you guys some things in there. There we go. Okay. Alright, so this says do not modify this file manually. That's probably good advice if you don't know what you're doing. If you mess something up in PAM, you can get locked out of the system. I mean, there would just be no way to actually log back into the system, and you would be really, really out of luck, guys. So don't mess with this file. That's good advice, unless you know what you're doing, okay? So we see some things here, like PAM permit, PAM deny.so. Alright. We can add certain things in here, like right here I could put like deny equals 5, okay? And if I do that, it's gonna say after 5 attempts, you know, it's gonna lock this person out and say, you know, you've been locked out, you need to contact your system administrator, right? I could also put under something like here on this line here, this password sufficient line. Okay, I could add a remember equals 7 here. And that would say, remember the last 7 passwords that were used, and they can't use the previous 7 passwords, okay? So there's just things we can tweak in this file. Notice here I'm going to do I'm going to do a quit exclamation point when I exit this file, alright? Because I don't want it to save anything I've done in this file, right? I did Q exclamation point. So I don't want it to make any changes to this file. I just wanted to view it and show you guys some things, but now I'm going to exit out of it, okay? Now I don't have to be worried that anything was changed on it. So that's the PAM file. The other file we can look at is password auth, vi.c/pam.t/password-auth. And it pretty much looks the same as the other file, okay? So both are used in conjunction with authenticating and getting people signed on your system. And I could do the same things in here. I could add that deny equals 5 or that remember equals 7 and other things like that. Again, I'm going to do a quit exclamation point here. So that's kind of the two files you look at when you're dealing with PAM. Let's head back to our PowerPoint here. So that's PAM. Super useful, and as it said, it can be used across multiple different systems and applications just as it is, and it'll work great for you.